Okay, so we're going to cover the homework of 5.2.1. So let's start with the first problem. We have now been introduced to the special right triangles. So the first problem is going to use the same ratio that we learned to figure out all the missing sides, right? So it says for the triangles below, use your triangle shortcuts from this lesson to find the missing side lengths, then find the area and perimeter of the triangle. So this is a 45, 45, 90 triangle. So it makes sense that this is going to be the same as that other side. So then this is going to be root 2 as well. And don't forget, the ratio is that then the hypotenuse is whatever the short side is multiplied by root 2. So the hypotenuse is going to be root 2 times root 2, which is going to be 2. Okay, now I have enough information to help me find two things. Help me find area and help me find the perimeter. So the area is 1/2 base and height. Base and height are the two sides that make the 90-degree angle. So it's going to be base times height. That gives me 1/2. Root 2 times root 2 is 2. So I get 1 square meter. It's pretty small. Okay. And then I need the perimeter. Perimeter is to add up all the different sides. So I'm going to go around the triangle and go root 2 plus root 2 plus 2. Well, root 2 plus root 2, that means there's 2 of them. So it's 2 root 2 and 2. So 2 root 2 meters. Okay. It doesn't say to round, so you're going to give the exact answer. And so you're going to leave your answer like so. Okay. All right. Moving on to the next problem. Now we have a 30, 60, 90 triangle. Because I see the 60 and I see the 90, this must be the 30 degrees. Okay. And I also see the hypotenuse is 10. So remember, if the hypotenuse is 10, then that means half of that is my shortest side. Half of that is going to be 5. And then the long leg is going to be 5 root 3. It's going to be the short side times root 3. Okay, perfect. Now I have all the three sides. I can figure out area and perimeter. Area is 1/2 base times height. Base and height, once again, is the two legs that makes the 90-degree angle. So they're going to be 5 root 3 and 5. So 5 root 3 and 5. So when you're multiplying numbers like these, that when it's in the root, you don't touch the root unless there's another number in the root. So a quick reminder of algebra, where when you multiply this, the outside number multiplies together. So you get 1/2, you get 25 root 3. So what happens to the 1/2? The 1/2 gets multiplied into the 25. So you get 25 root 3 all over 2. And there's one mark there, so it's square feet. Okay. Doesn't look very pretty, but that is the notation for this particular area. Okay. Perimeter, we're going to walk around the whole shape. So we're going to take 10 plus 5 plus 5 root 3. So 10 plus 5 plus 5 root 3. That will give me 15 plus 5 root 3 feet. Okay, and that is the exact answer for those two problems. Okay, scrolling up. So now it says, use the relationship found in each of the diagrams, solve for x and y. Assume diagrams are not drawn to scale. State which geometric relationships you used. Okay, so in a lot of these shapes, in a lot of these diagrams, you may need to solve for things that you're not being asked for, and then you're able to solve for the things that you're being asked for. For example, in part A, I'm going to zoom in here. I can't directly figure out what x and y is. However, if I focus on just this triangle here, I know that all triangles add up to 180 degrees, and that triangle is just missing one angle. So I'm going to go ahead and figure that out. I go 180, right? I can use my calculator or use, my head, up to you. So take 180 and I subtract the 70 degrees and I subtract 41 degrees. That will give me the missing angle to be 69 degrees. All right, that's great. Is it helpful? Yeah, it should be, because then it tells me the vertical angle to the other side. This is also 69 degrees. Now I can look at a second triangle here and go, okay, now I have another triangle here. And that also must add up to 180. And now with two missing angles, I can figure out the third angle. I mean, with two given angles, I can figure out the missing angle, right? So I can go, okay, well, I have x plus 69 plus 58 must equal to 180. 69 plus 58 is 127. So x plus 127 equals 180. So x must be 53 degrees. All right, so I'm able to figure out what x is. Okay, what about y? Well, y, you got to look at another relationship. You got to look at the fact that, hey, y makes a straight line this way. So this angle 69 and this y will add up to 180 because they make a straight line. So then you can say, okay, well then 69 plus y equals 180. So that y must be 111. Okay. And that's it. You've solved for x and y. Okay. Okay, so I use a lot of relationships here, so I want to make sure I mention it because it says state which geometric relationships you use. So I use that there's a triangle angle sum because I add up to 180. So that was the first relationship. Second one I use vertical angles. And then last but not least, I use linear pairs to solve for y. So linear pairs, because I know that linear pairs means that I have two angles that make a straight line, so therefore they're supplementary, and then also add up to 180 degrees. Okay, all right, sliding over to part B here. Okay, so again, I always ask myself, why do they tell me things, right? Why do they tell me there are parallel lines here? Okay, so if there are parallel lines here and you have a transversal, then you have, if you recall, then you have these alternate interior angles. So that means if this is 47 degrees, this is also 47 degrees. Awesome. I don't need to work anything out. I can go ahead and set x equals 47 degrees, right? And remind myself that's because of alternate interior angles. Okay? All right, so that's one. Next, how do I find y? Well, can I look at the triangle again? So this is where you got to look at more than just what's given here or what's being asked of you. So now let's take a look at a triangle relationship. I know these angles right here make triangle. So I may want to figure out this missing angle first, because then it will be linear pair to y again. Right? So I need to figure that out first. So I take 180 minus the 32 I see here, minus the 47 I see here. So it tells me that angle right in that triangle is 101 degrees. So that was using triangle angle sum again, right? It's that the fact that the angles in a triangle always add up to 180. Last but not least, that 101 and the y are linear pairs, so they add up to 180 degrees. So you go 101 plus y equals 180, so y must equal to 79 degrees. And this is the fact that this is a linear, well, the two angles, the 101 and the y, are linear pairs. All right, so not only do I solve, I need to say why. So these are all the reasons, right? Okay, moving on. Again, it tells me parallel lines, so I'm going to see what parallel lines what relationships I have here. So I have parallel lines here. Awesome. This is a transversal. So I'm going to look at the first transversal here. The first transversal here gives me some corresponding angles. So 127 is corresponding to 127. So this is 127. All right, so first relationship, I have corresponding angles. Then, because that 127 is right next door to the x and they make a straight line, I have linear pairs again. So linear pairs, and it allows me to say x plus 127 equals 180. So x must equal to 53 degrees. Okay, now do I have enough to solve for y? I may. Let's see. So now I have a different transversal, right? So I have a different transversal. So I'm going to ignore the idea. I'm going to ignore the other one. This is another transversal. I have another corresponding angle here. So I have 83 and 83, right? So those are corresponding angles again. I don't need to list the reason because I already listed it. So I know that I use corresponding angles again. And then if you see 83 and y, these are vertical angles. They're across from each other. So I need to use vertical angles to figure out that y is also 83 degrees. Okay, beautiful. Remember, these are all things we learned last semester. So we're using all those tools again. Okay? All right. Last but not least, what does this say? It doesn't look right? I mean, literally, it doesn't look right. But you know that if this is 45 degrees and 45 degrees, this must be a 90-degree angle. It looks horrible. So what I would suggest to do is to redraw this so it makes a little bit more sense to you, right? So I have the 90 degrees this way. So maybe for me, it could be a little bit easier if I draw it this way and I see, oh, this is a 90. And that's a 45 and 45. If that's the case, then these two are exactly the same. And then based on the picture here, I have 3 here. Oh, that's not so bad because then I can see that the other missing side, this bottom side y must also equal to 3 because they're the congruent sides. And then so my x, my hypotenuse, must be 3 square root of 2. Okay, so what did I use? What was the geometric relationship? I used the fact that this is a 45, 45, 90 triangle. So that's a shortcut I used. Okay, all right, I'm going to zoom out. And that's it for this problem. Okay, so it's on graph paper, graph AB if A equals 1, 6 and B equals 5, 2. All right, so I need graph paper to do this. Okay, so number 54, it says we're using graph paper, so I'm switching over to graph paper. If you could, I would strongly suggest you do the same thing. So this is 5-54. It says on graph paper, graph AB if A is 1, 6 and B is 5, 2. Okay, so that tells me I don't need much on the negative. So that means I'm all in first quadrant. Okay, that's nice. So I'm going to draw my X and Y axis. Okay, so X and Y axis, that should be enough. Always label at least 1 point so you know your scale. I'm going to go 1, 2, 3, 4, 5. That tells me 5, and this is also 5. Okay, so that should be enough for me to draw my picture. So A is 1, 6, so 1, 6 is A. B is 5, 2, so B is here. Okay, so I'm going to take this and go ahead and connect these because you're trying to figure out AB, right? It says draw AB. Okay, find the length of AB, leave your answer in exact form, and do not approximate with a decimal. Explain your method. So for me, I believe the easiest way to approach figuring out how long AB is to draw a right triangle, because we know we are familiar with right triangles, right? So we can look at this as, we can look at A and go down the first leg this way, and then make your horizontal case this way. So that way you have 2 legs there. This will make 90 degrees because X and Y always make 90 degrees. And you can actually count the boxes. So you know this is 4 and this is 4. So in order to find your length of AB, you can now use Pythagorean Theorem. Or you can remember that, hey, it's 4 and 4, so they're congruent. That means this is a 45, 45, 90 triangle. Therefore, AB must be 4 root 2. Right? So that's a lot quicker than you using the Pythagorean Theorem. Okay, so then we can answer part A. Part A says find the length of AB. So the length of AB, you write AB equals 4 root 2. Remember, with the bar on top, you're talking about the line. Without the bar on top where it says AB like so, you're talking about the length of that segment. So how long is A to B? Okay. Then it says reflect AB across the y-axis to create A prime, B prime. What type of shape is AB, B prime, A prime if the points are connected in order? Then find the area. Oh, I did not look ahead on this, but I think I have enough space. Okay, I am going to go ahead and reflect it. So I got to erase all this other stuff I had there. Okay, get back to just my AB here. Okay, I'm going to reflect this over to the other side, reflect it over the y-axis. So here's my reflection. That's my first point. That's A prime. Right? Remember, it's going to be the same distance from the y-axis. And then your B prime is the same thing. You're going to count 1, 2, 3, 4, 5. Ooh, right on the edge. B prime there. Okay, so A prime, B prime is going to look like this. And it says you're going to connect them in order A to B. So A to B, and B prime to B to B prime, A, B, B prime, and then A prime, and then connect it back. So what kind of shape is this? This is a trapezoid, right? You have 2 parallel lines, and then the other 2 are not. And in fact, this is even more specific because you can tell because it's reflective that AB and A prime, B prime are the same. This has an even more specific name. This is an isosceles because there's 2 congruent sides. Isosceles trapezoid. Okay. Then you need to find the area of this trapezoid. So don't forget, we have a nice formula for area of a trapezoid. It's 1/2 base 1 plus base 2 times the height. So that's 1/2. What is base 1? How long is this top? It's 2 boxes, so 2 units. How long is base 2 down here? That's 5 and 5 on each side, so that's 10. And then what is the height? The height is right here. It has to be perpendicular to both bases. So that's 4 boxes there. So I get 1/2. 12 times 4, so that is half of 12 is 6. 6 times 4 is 24. So 24 square units for this particular trapezoid. Okay? All right. Okay. In the next problem, we're looking at probability. So it says on number 55, in a random sample of 10,000 college students, a research company found that 35.7% were involved in a club and 27.8% studied 4 or more hours per day. So two separate events here. One is people going to clubs, one is people who study a lot. Okay. When they reported their findings, the research company indicated that 53.4% of college students were either involved in a club or they study 4 or more. So this is an event where it's something or something, right? So given this information, what is the probability that a college student involved in a club and studies 4 or more hours per day? So the way to look at this is to see that this is event A, involved in a club, and event B, studies 4 or more hours, okay? And this next one is in a club or, keyword or, study 4 or more hours. And what we're looking for is and, right? So remember, there was that really awesome formula when we were working on this before, is that the probability of the first event plus the probability of the second event minus the probability of the combined event equals the probability of the or event. Okay? So what is the probability of the first event? The first event was 35.7%. The second event was 27.8%. We don't know the and, right? This is what we're looking for. The and, we don't know. So X, we don't know that. But we do know the or event was 53.4%. Okay, so once it is set up, it becomes a very nice, easy numerical equation. So you go 35.7 plus 27.8, and you get 63.5 minus X must equal to 53.4. Okay, subtract 63.5 on both sides, so minus 63.5. And that will get you negative X equals negative 10.1. Divide by negative 1 so that you get X equals 10.1. So the probability of involved in club or studies 4+ hours a day, or, that's a key point, right? Oh, sorry, not or, and. This is the and. That's what we're solving for. Sorry about that. And, right, is equal to 10.1%. Okay? So you have the A, you have the B, you have the or, so you can solve for the and. Okay? All right. Next, fill in the blank oval so that each flowchart is correct. So X is a prime number, right? And then how do I get the conclusion that X is equal to 2? Well, then you can say 2 is prime, right? So because X is a prime number, 2 is also a prime number, then essentially what we did was got rid of the prime number and said X equals 2. And that's how the conclusion becomes X equals 2. A little bit tricky, so think about that a little bit more. Okay? All right. Next one says the triangle is a 45, 45, 90 triangle. The hypotenuse of the triangle is 6 root 2 units long. So in that case, then this triangle, right? This triangle is 45, 45, 90 triangle, and we have the hypotenuse. So so again, let's kind of draw this out. We know that we have this triangle to be a 45, 45, 90 triangle. We know that the hypotenuse is 6 root 2. What does that tell me? Then the sides are 6 because of the shortcuts. So I would say each side is 6 units. That's a conclusion. Okay? All right. Next, it says write an explicit equation for the following sequences. So it's again asking you for the formula that gets you these equations, right? So let's see. From 500 all the way up to 2,000, I believe that's adding 1,500. Does that work in the next one? Yes. If I add 1,500, I get 3,500. So this is an arithmetic sequence. So that means that my formula is, right? My formula is A sub n equals the first number, 500, plus n minus 1 times that common difference of 1,500. All right. So yes, we do need to clean this up a little bit, right? So I get 500 plus, distribute the 1,500, 1,500n minus 1,500. So I get 1,500n minus 1,000 to be my formula for A sub n. Okay? And that's it for that's what it's called, the explicit equation, which is the formula right here. Okay. Next problem seems like it's jumping big fast, right? You have 30, then you have 150, then you always 750, and then 3,000. So I believe this is jumping by multiplication. So let's see, what number are we multiplying by? So a quick way of figuring out what you're multiplying by is take the second number, divide by the first number. So if you take 150 divided by 30, you will get 5. So that means you're multiplying by 5. And now you can check, is that pattern true? Yes, because you multiply by 5, that's how you get each number. So this is geometric. Okay, geometric has a different explicit formula. The formula says a sub n equals your first number, 30, times your ratio, so the ratio is 5, and then to the n minus 1. Okay, all right, again, I would say that if, in the next level at Algebra 2, you will clean this up a little bit more, but right now, just for the sake of our review, we are not going to clean this up more. Okay, all right. Next says, decide if each pair of the triangles below are similar. If they are similar, give the sequence of transformation that justifies your conclusion. If they're not similar, how do you know? So again, reminding ourselves, there's only 3 ways to prove similarity. There's angle, angle, side, angle, side, 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 similarity. Okay? All right, so if I take a look at A here, I see all sides. I don't see any angles. So the hint for myself is I have to check and see if this is side, side, side. So what do? I take short side matching short side. So 10 to 15. Does that match medium side to medium side? 11 to 17. Does that match long side to long side? 12 to 18. Okay, so reduce when you can. 10 over 15 can reduce to 2/3. Beautiful. 11 over 17 cannot reduce. But then 12 and 18 divide by 6, then you also get 2/3. So right off the bat, you can see, since I cannot reduce that middle one to a 2/3, it is not going to be the same ratio. So this one is not similar because the ratios are not the same. So not similar. Right, so not equal, not equal. Okay, all right. If I go ahead and move on to the next one, I see 2 sides and an angle. All right, so then I can prove that side, angle, side. And what's even better is the sides are the same. So if I set up my ratio, 5 to 8, is that going to be equal to 5 to 8? Well, they're the same fraction, so yes, they are equal. So now I do have side, angle, side. So by side, angle, side, these are similar. So I'm going to say triangle and just go GHI, similar to triangle JKL by side, angle, side, similarity. And what kind of transformation? I would say it is a reflection and then dilation, because it reflected over to be the other triangle and it got bigger. So we'll say reflection plus dilation. All similarity problems are dilation because it's a different size. It could be smaller or bigger, but it's a different size. Okay. All right, next one's really nice because we kind of briefly talked about this in the previous homework. These are both equilateral triangles because all 3 sides are the same. So all equilateral triangles are always similar by side, side, side. So triangle MNP, similar triangle, and you can go in any order because the sides are all the same. So I'm just going to go QRS by side, 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 right? All equilateral triangles are similar, okay? So then what happens here? I believe it's a rotation. You got to rotate a little bit because otherwise one's pointing up, one's pointing down. So what transformation happened here? You rotate it, so rotation, and you also dilate because you got a little bit bigger, right? Dilation. It's a very good reminder of what we did in first semester, okay? All right, last but not least. Okay, well, I have these 2 sides. I can figure out the third side because I have Pythagorean Theorem, right? So let's see if the third side will really, figuring out the third side will really help me out. Because I don't have enough here to do side, 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 because I need 3 sides. If I want to do side, angle, side, I could, but this one, the WXY does have side, angle, side. So side, angle, side, right? But then the first triangle doesn't. I need side, angle, side. So I do need to use Pythagorean Theorem first to figure out that missing side, and then I can check and see if this will give me similarity. Okay, so I'm going to use the Pythagorean Theorem and say, okay, I have 3 squared plus b squared, that's the other leg, equals 5 squared. So 9 plus b squared equals 25. Subtract 9, b squared equals 16. Square root, oh, this is perfect, so it's 4. So this is going to be 4. Okay, now I can go ahead and check just the 2 sides to see if they're proportional because I have an angle here. So short side to short side, 3 to 6, is that the same as 4 to 8? 4 to 8. I can reduce the first to 1/2. I can also reduce the second one to 1/2. Therefore, the ratios are the same. So beautiful. I can now say triangle VUT, similar to triangle WXY, by side, angle, side, similarity. Okay, so for me, let's see, well, how do I transform to this triangle? So I believe that this is a rotation because you got to turn it so that the right angle is in the right place. So there's a rotation here, and because it's bigger, you need dilation. Okay, so dilation to get to the next triangle. Okay, all right, I think that's it. All right, that's it for our homework.